All right, next up we have Tina Greenfield with the Iowa Department of Transportation. She is the road weather coordinator. She has spent the last 21 years in the winter operations team, helping with winter maintenance research, contracts, data systems, performance measurement, and business analytics. All right, thanks, Tina. Go ahead.
Thanks, Kyla. Thanks, everyone. I'm going to talk a little bit about what we use in Iowa. Going to the next slide, please. So I'm going to start out with material tracking tools that we use to make sure that our salt numbers even stay within the bounds and don't necessarily need any kind of special monitoring. And then we'll go into the monitoring itself, how we do the scanning, and then how the scan results turn out. So next slide, please. So I'm going to start here with the tracking tools because at Iowa DOT, we track all the salt that goes into our sheds through purchases, whatnot. We track sales to entities. We track when material is used in brine making or out on the road. So we have basically a stockpile inventory that we manage, and that should be just like your checkbook. It should show what's actually happening, but sometimes things kind of get out of whack. So the first line of business is to make sure that we can get this bookkeeping managed the best that we can. So we start with tracking tools to make sure that we can catch any errors in that bookkeeping before it blows into a big inventory problem. And we start with visualizations that are easy to kind of find those errors, that give some kind of context to the numbers that you're seeing, and help find any particular errors in our accounting, so to speak, before they get bad. So go on to the next slide here a little bit. This is an example of what we call our salt book, our salt ledger. It's all of the ins and outs that happen at a particular garage. So if someone is faced with an issue with their salt inventory, or they're looking at the shed, they're looking at what's on the resource management system, and it's not lining up, they can go to this system and they can get an accounting of every single in and out of that shed that has been logged since the beginning of the year. And they can even back up to previous years. So like in this case here, there's an entry of 0.0014 tons of salt. And you can sit and think, well, did they really put one shovel full of salt into that function 682, which is aggregate, or basically salt sand mixing? I kind of doubt it. So this is a way that you can kind of look through and say, oh, maybe that number should be something else, and maybe that is part of the error difference. Go on to the next slide, please. And then another tool that we use is targets. So we have a method that we can kind of compute an expected target salt use, because sometimes finding an error is kind of difficult. 2.5 tons, 25 tons, and 52 tons, which are common ways that one can maybe typo or mess up a number when they're entering something, can't all be realistic. It's just all based on the context of what was happening that day, who knows? So this system helps us kind of find the needle in the haystack amongst numbers that might look reasonable, but are out of the context of that day. And so what it does is say, we would have expected that they use something more like the 25 instead of the 52. And you can look at these big jumps and go, wait a second, what happened this day? Even when it was a number that could very easily be overlooked because, out of context, it could be taken as reasonable. Next slide, please. So if all of our little checks and balances don't result in anything that straightens things out on paper, we do have the ability to do salt adjustments and salt shed scans. And we opt for a handheld LiDAR unit, Go on to the next slide. This particular unit is our second unit. We've been doing these LiDAR scans on our salt piles for 10 years now. We have a ZEB Horizon, which is a slight upgrade from the unit that we started out with, which was one of the original ZEB units. The ZEB Horizon has a 100-meter range, a 3-millimeter accuracy, and can spread out 300 laser points in a second. The units are shown on the top of the screen there. Held in one hand, basically, you just walk the pile. The brains of the system are in that over-the-shoulder black thing there. That's where all of the logging happens. And you just basically walk a loop around the pile and collect the scan. And then a very important part of our scanning process is a portable lab scale and a Walmart bucket. And that's important because, go on to the next slide, please. The process at Iowa involves taking a density sample at each shed. And in fact, sometimes we take a couple. You can visually tell the difference between certain loads of salt. You know, sometimes part of the shed is loaded with salt from a different company, or maybe it was delivered at a different time. And the salt has variety in its weight, its gradation. Some salt is very large and chunky and has a lot of air voids. Some salt is very fine and has a very densely packed matrix to it. So we try to take a sample or two, depending. We boot up the scanner. We take a walk around the pile in a loop type shape if possible, because as we saw on the previous presentations, the scanner has to be able to see in order to measure. If it can't see it, it can't measure it. So we try to get the scanner up along the sides and try to get visibility by raising the scanner or something like that, so that we can get down in any corners of the shed that might be, you know, off the edge of a slope a little bit, basically so that the scanner can see all of the salt area. We shut down the scanner or go into another one. It takes us about 10 minutes to boot the scanner and run a scan on a shed. The scanning process is actually by far the quickest part of the whole thing. Go on to the next slide, please. And once we have taken the scan, we go back to our office, and this is what we get. Unlike some of the other systems that you've seen, ours, of course, is a handheld unit. It's not trained on any one garage or any one shed. We have 200 and some salt buildings in the state of Iowa that we manage. So it's up to us to take basically a raw scan of everything and trim it down. Next slide, please. So in that previous picture, you saw the dome. And of course, we're only interested in the salt that's in it. So we get this 3D rendering of the entire environment that scanner was exposed to. And we trim away the stuff that's not salt. So any part of the building, if you had any curious bystanders around while you were taking the measurement, they all need to be basically cleared out of the sample before we can analyze it. And for that, we use a quick train modeler. So after we have the scan trimmed, then now we can calculate the volume underneath the salt profile to the floor level. And this is where we use that salt sample to estimate our density. If you take a really close look at the picture that's on the top right, you can see that the scan itself is so detailed that you can even see the footprints of the person who walked up each side of that main peak area. The scans are very, very precise, but it's that salt sample weight that is probably the biggest variable in our scanning procedure. We take the volume of that pile. We use the salt density measurement that we took of that pile or of that particular shed, and we compute the tons out of that. Next slide, please. And so our procedure for an adjustment is that an admin of the resource management system, like me or my coworker Craig, can go in and we can put in that adjustment. We typically only adjust for scans that are within 5% of the difference from record. And again, a lot of that is just because of the differences that you can get in that density measurement. And again, we found that that can vary quite a bit, not just shed by shed, but also from different parts of the shed. So since we can only sample what's exposed, we don't really know the density or how it might be compacted down underneath at the bottom of the pile. We kind of have a little bit of a wiggle room so that if it's plus or minus 5% of our recorded amount, we may or may not change it depending upon what the local forces want to do. And then as far as kind of how this is operationalized, we have had all of our sheds scanned with a LiDAR unit, but we don't scan them all the time. We tend to scan on request. So when when people notice that something's not quite right and they're not real sure, they're looking at their records, they're looking at their salt pile, and they don't think it lines up, that's when we are called in and we'll do a scan. Some garages also choose to scan every year just as part of housekeeping, but most of the time it's as requested unless we're chasing a very particular problem at a site. Next slide, please. So summary of my presentation is, first line of our defense is making sure that our systems for recording salt use and receiving salt use are have checks on them so that we can catch errors before they grow. We also use visualizations to help things that maybe have found their way into the recorded system, but maybe need a little bit of looking into just because they look suspect. And then, of course, if we can't figure out the problem on paper, then we have chosen the handheld LiDAR system because we have one LiDAR system and we have 250 buildings or so. So that allows us to buy one unit and then service all of our locations. We've also shared this LiDAR unit with other offices within the DOT. Our environmental unit has used it on many, many occasions. Our bridge folks have as well. Anytime we need to get basically a measurement of what a shape looks like, we can use it. So we've used it for our own salt stockpile. We've used it for aggregate. We've used it for archaeological sites next to construction. We've used it for bulk material and just about anything at the DOT. We can share that around. The scan time is very short. The longer part of the ordeal is just traveling to and from a site. And then the kind of in between is that there's about a half an hour of work wrapped up into the scan processing. We've been satisfied with the results, and it's been great for settling the amount disputes, especially when you've got an uneven pile that's really hard to estimate, or it's a situation where you really don't want to trust the trained eye, so to speak. So that's all I have to say about our system here. I'll be glad to take questions in the question and answer box. And Kyla, back to you.